welcome to our second CICS session for the day, 3 o'clock session. Jenny's here going to be talking about enhancing the foundation of CICS. There's still people coming into the waiting room, which I have noticed seems to be a feature of the last few minutes. So I'll just talk for a brief moment while we're admitting a few folks. Jenny's going to be talking about CICS foundations. Well, I think we'll kick off. There's quite a few people turned up the last minute or two. Okay, Jenny, if you can take it away. Thank you very much.
Thank you, Rob. Good morning and good afternoon, good evening, everyone. I'm Jenny He. I work in CICS development in IBM Hersley Lab. Welcome to this session 2AE. So I will be going through the CICS Foundation enhancement over the past recent release 5.6. I've been in CICS development since the first version of 5.1. So I've been doing CICS development for event processing, CICS policy, IPIC, HA enablement, the async API suite. And also recently I moved on to enhance the CICS monitoring and the statistics, as well as other foundation areas. So I'm very glad to take you through this topic. Okay. So as you may have heard messages on the CICS TS application server, since version 5.4, we've introduced a Node.js hosting as a hosting environment. And also we introduced the Java Enterprise Edition version 8 into the version 5.4. So really the CICS TS server for ZOS has become very powerful mixed language application server, which can host not only COBOL, PL1, C language, as well as assembler, Java, and Node.js. And they all share the common context with CICS being a fantastic transactional environment and provide you the security environment for it, and also the monitoring and the management as a core capability of it. So really the current way moving forward is for the business companies is to think whether they will, what to do with their current application with evolving cloud enablement. So whether they can rehosting, rewriting, or replace their current application are some decisions they're going to facing and to make. So for the CICS, we continue to enhance the CICS suite as a whole, but in particular, the foundation we wanted to provide still as a very solid foundation, as well as moving with the current evolving world. So the CICS TS version 5.6 is GA'd in June 2020 this year. The 5.6, they continue with the minimum requirement of EC, IBM Z Enterprise EC12, or subsequent Z architecture processors, and also the ZOS 2.3 as operating system. We need the 64-bit SDK for ZOS and the Java technology version 8. So that's a minimum requirement for CICS TS. So in this presentation, I'm only going to talk you through some core foundation enhancements that CICS delivers. There are areas like Java, like application development, that those areas you will be hearing from my colleagues in the later GSE sessions in this track. So keep an eye on that. For the CICS TS server version 5.6, we improved the areas we've listed here. So on the application development, we would like the application developer, not only the COBOL developer or traditional Z program developer, but also Java programmer and other off-platform or the open platform developer be more agile with more comfortable with creating applications and also for Z without knowing much of the Z knowledge. So also we improved in the management space for system programmer to better manage the system, spend less effort, and also on the security and the resilience side to making sure the system is more secure and the system can react to workload influx of workload without taking the system down or impacting many other workloads. So let's go through these 4 areas and focusing on the core CICS functions we provided in the 5.6 release. First of all, I'd like to go through some enhancements we have in the application development area. So I've mentioned the Node.js is introduced into the CICS TS version 5.4. Throughout 3 releases, we are now supporting the Node.js version 12. So why we want to host the Node.js applications? As you might know, the Node.js is a server side of JavaScripting language. So currently the web browser using JavaScript, and it's being in the very competitive space for various browser providers. For example, the Google Chrome and the Firefox, etc. They compete on the web browser performance. So that making the web browser now a wide way to access services from backend. And with a large community of developers who provide the JavaScript front end, and with familiar language of syntax on the Node.js, which provides the server side of capability. So we enable a large pool of developers can develop front end as well as accessing between the backend as well. So the Node.js now come to a very server-side, very similar syntax to JavaScript, and it's lightweight and single-threaded and performed better than even Java, C#, etc. Apart from that, we mentioned a large pool of developers, and it also have a large ecosystem. So for example, people can share their package through the Node.js package management, NPM, then they can, with the build tools, development tools, and those build tool chains available. So making the development and deployment process very agile and very lightweight. So that's why the Node.js we now have, it's a growing community for, and so CICS would like to host this Node.js applications for you to, if you were having those kind of application and accessing the CICS application, for example, you can co-locate it in the CICS environment, so it will largely improve the response time. And also the CICS, if you have the Node.js application hosted in CICS, CICS will use an optimized way to call CICS programs. So therefore you will have less CPU impact on that as well. The deployment and the management on the Node.js application is the way we manage Java application, for example. So we use CICS bundles. So with those benefits, so hope it with the Node.js support in CICS, we hope you can consider to use the hosting your Node.js in CICS and to help improve your response time, making use of existing your backend services and use Node.js as aggregate APIs and or even to access external APIs. So that's our enhancement around Node.js 12. So next one I'd like to talk about is DPL Commarea limit. DPL is dynamic program link, which enable you to call a program on a remote CICS region. The support of DPL has been there since the 1980s. However, we have a document saying the Commarea limit. So on the screen on the right-hand side, on version 5.5 and earlier, we have this text in the length, this parameter saying this value cannot, must not exceed 24 kilobyte if the camera is passing between two CICS servers for any combination of product version and release. So why is that? Commarea is 32 kilobyte area. So why is that? Because when CICS need to communicate with another CICS region, CICS need to, for example, to create the distributed identities, ICRX, for example. So you need to make use of some part of the Commarea. So it depends on how much data you passed in. So you may not experience that problem, even you may not pay attention to it because your application runs perfectly fine. But if that limit is exceeded, your application would get AXGB banned. So this happens for MRO restriction for MRO and for ISC connection. For the IP-IC connection, it doesn't have this restriction. So for 5.6 region, between 5.6 region, now we enhanced it. So you can make the use of the full 32K kilobyte of Commarea. And that's has been improved for 5.6 CICS regions over MRO connection. But the DPL over ISC connection, it would currently still have this restriction because that connection is we stabilized, so we're not making any improvement over it at the meantime. The next couple of enhancement for around application level is around web application. So there is a HTTP patch method, which can allow program to update some partial resources. For example, just one field in one resource. So instead of sending the whole record, you can just use the patch method to send the field, the value to update. Previously, CICS doesn't support this HTTP patch method, but now we support this on 5.6, and the request is passed to application code. And as you can see, we also enhanced the web send and the web converse API. Sorry about that, for it to be able to use patch as a method. The next one is HTTP options support. So the options request is often coming as a client to ask the server what kind of method I can use. Can you tell me? So we now be able to support this, but there is no security checked on this. You can configure the HTTP server with options PGM options program, and the CICS provide a sample handler program called DFHWBOPT. So when you configure that and when you get an option HTTP request coming, the program is invoked, but the analyzer program, which is a URM parameter section specified, that one is not invoked. So we support this on 5.6 through the TCP/IP resource definition way. But if you have 5.5 and 5.6, you can still get this same functionality through APAR PH16692. However, you use a feature toggle instead of using a TCP/IP resource manager. So that's around the foundation core part of what we've enhanced for application development. So next, section, I'm going to look at the management section. What enhancement we put into CICS to enable you to better manage the system environment. The first area I'd like to go through is CICS policies. You may have heard CICS policy. It came into CICS through from 5.1 release. So what is CICS policy and how does it compare with the event processing, which can emit business event as well as system event? So the CICS policy is really for you to monitoring your system resource usage. For example, how many, whether the file is enabled or disabled, whether I will show you some of the rules. Well, we will be in the next page, but through there you can get an idea what kind of system resource you will be monitoring on, and what kind of system state you can monitoring. Then with that monitoring, you can take actions at the system level to either abandon task or reject certain request, for example. So as a CICS system administrator, you would be this would be very useful for you to monitor in this way, and it's real time running in the CICS region. So how does it compare to application events in CICS? The CICS policies, you can define rule, but those rules, they do not monitor or capture any business logic, while the application events in CICS can do that. So really, if you want to, if it's an application related monitoring or capturing, you would use application events. But if you're don't care what the application logic is doing, then you can use policy rules. And another difference is the policy can have an action called emit an event. But the event get policy event will not be transactional or synchronous, which means the event as a result of policy rule being triggered, it will not be as part of the unit of work of the CICS task, which triggered that rule. We have a system rules coming into the CICS policy, and we are seeing it as a strategic replacement of the CICS system events. So really, it simplifies your management of system-based rules by putting them in one place in CICS policies. So as a system programmer, you can manage all the rules you want to monitor the system resource, or as a CICS as a policy, instead of some are in event bindings, some are in CICS policy. So that simplifies your management from that point of view. And each rule would be able to have its own action. So that's a difference comparing to the event binding. And you have multiple choices of action. We will show that later, and a more variety of actions. In order to create such kind of policies, we provide graphical user interface through the CICS Explorer for you to edit and create the CICS policies. So after the Explorer created that, you can export to ZFS directory, or you can check into your enterprise version system, then through other build route to put into the ZFS, then define into CICS as a bundle to install it and enable it in the CICS region. So this chart shows you what are the available system rules and what are the available task rules you can use up to the version 5.6 CICS release. The ones with the red stars, they are new in 5.6. So as you can see, for system rules, you can monitor the bundle status and the DB2 connections, file enable status, MQ connection, IP connection, MRO, or pipeline, program, transaction, abandons, etc. And for task rules, that would for example, it can monitor, you can say how many asynchronous API requests to start new transactions, a task I can allow it, not allow it, I can monitor on, for example, and how many database requests and how many CPU time or what's the elapsed time for a task. You can monitor on that. In the recent enhancement, we shipped APA PH26145 for task rules, which you can specify context filter, which are the user ID and the transaction ID. You can say this rule would only apply to certain transaction ID and certain user ID. So that's a recent enhancement we shipped as an APA to the 5.6 of CICS. For the actions you can take when the rule is triggered, for system, we have slightly different action sets for system rules and the task rule. For the system rule, it can emit a message, which is same as task rule, or emit an event, which is the same as a task rule. And you can put in some static data with that event. And then for system rule, you can say reject exec CICS request with in IMVREQ reason. So that means if this rule is triggered, this task, I don't want this task to go ahead, then you can reject this, then up to the application to handle what to do with it. And lastly, but very, very important is you will be able also to set the SWLM status. So that's health status for the CICS region if the rule is triggered. So that is new in the CICS TS 5.6. For task rule, the only one thing, one action different is you can abandon the task. So that's a difference. So next couple of charts, I'm going to go through some Dumpcodes enhancement. Before the CICS version 5.4, for Dumpcodes, it's not RDO defined. No, you can use set Dumpcode or add or remove in that way, but it's not as a resource in CICS. So we have enhanced that. Now you can define a dump code resource. It's supported through CEDA transaction or DFHC SDUP or exec CICS create and exec CICS CSD to create a dump code resource. It can install at the region startup time, so you do not need to write a program list table to PLT program to do so, to save you assembly. But you cannot define it through a bundle or CPSM BAS. So that's the part we don't yet see. It's necessary to support that. Then you can't discard it with that, with a dump code RDO resource. Yeah, so you continue to use the set dump code, system code remove or transaction dump code remove command. This is a CICS screen when you have a defined dump code happens. So here you can say you define a dump code called T-Tilling. So it's one of my colleagues who created shared me this screen. So he defined a type, dump code type as a system one, and you can have options selected for that dump code. Along with that, we also improved the SDUMP suppression options. As you know, the dump SIT parameter, you can use yes or no at the meantime to either no is to suppress all the system dumps except the kernel dump you can't suppress, or you can say yes, which is to allow all system dump to be taken apart from the ones, say, suppressed by a dump table. But what if you want only taken the ones in the dump table, but you want to suppress all the other system dump? So this is particularly would be useful in a production system where you don't want many dump to happen, but you do want to capture certain important dump for the diagnosis of the problem later. So we provided a new option called table only. So you can use that option to suppress all system dump, except for those dump codes that have an entry in the dump table, allow the system dump to be taken. So if you have any implicit entries added to the table by CICS, that would means a dump table action node, so no dump will be taken for those entries. The last one around the management part is feature toggles. The feature toggle is introduced in CICS from CICS 5.4. Feature toggle is a way of allowing you to specify certain options at the CICS startup time, but without specifying as a SIT parameter. So it's really, we see it as a way to provide you a temporary options for CICS startup and how it behaves. So previously, to specify feature toggle, you can specify for each region, or you can specify one for a group of CICS region. But from 5.6, we changed the way you specify the feature toggle. So now you can USS directory in your SIT parameter can point to ZFS directory. For example, here you have a DFH config folder there, and you under that DFH config folder, you would have this feature toggle.properties file. So the name is fixed. So that file would be able to work as a common configuration file for a group of regions we can share, which point to the same USS config SIT parameter being specified. So what happens? You want that the ones specified in the group level, some of the feature toggle being as a final. You don't want the region level to change, so you can use a finalize this name to in front of a feature toggle. So which would mean that particular feature toggle in the file will not be able to change by a CICS region. Then for individual CICS region, here I have a region called IYCWZ CAA. This region, I wanted to have its own feature toggle property to maybe override or maybe adding additional feature toggles which are not in the group level. So that's where you would specify for individual region. Okay. Lastly, I'd like to mention the CICS generating the IBM workload interaction correlator data. So CICS 5.6 is now participating to generate this SMF type 98 and the subtype 1024, especially for CICS for this data. So this kind of data, SMF data, is generated every 5-second interval, and there is no, you can't change that interval. And it's a summarize of across all the CICS regions and all the jobs in the ZS system. For example, how many tasks it run, what's the response time and the CPU used, what's the average, and is any exceptional transactions run during that 5-second, what's the exceptional one, and which job, which CICS region have this exceptional transaction. So it's not only CICS participating, generating this SMF data. There are other products like IMS also generating the subtype 1025 SMF98 data as well. And also ZS supervisor already generating the SMF98 subtype 1 data. So at the meantime, if you have this feature enabled, you would be able to see these 3 types of data if you have those products running in your system. So those data can be analyzed by analytic region engine, for example, the IBM ZS Workload Interaction Navigator, to correlate between what happens in ZOS and what happens in CICS and what happens maybe in IMS, to find you some correlated highs and peaks through those through the time the SMF is being collected. So that will help in a higher level of problem determination, finding out which component to concentrate on for when you look at complex problem. That feature you would need Z14 or above and ZOS 2.3 or above with the ZOS APAR A57165. And also the CICS capability is also provided for 5.4 and 5.5 through the APAR PH16392. So if you have those CICS, this APAR installed on those 2 release, and also if you have 5.6 CICS release there, and the ZOS is enabled with this workload interaction correlator, then you would see when CICS start, you would see a message DFH MN 10119 message say the registration successful, and you will CICS will report the weak data generation is active. This is a very brief picture to show what looks like when you get this CICS data, SMF98 in workload interaction navigator. So the yellow lines shows the CICS, it's a response time per transaction throughout a 15 minutes interval. And each dot on this graph is every 5-second collections. As you can see, the response time in this interval 15 minutes, it stays quite low for quite a couple of minutes, then went up then it went down. So that represent some activities in the region happening during this time. There is a more detailed session on this, the workload interaction correlator and navigator in the GSE UK track. I think it's tomorrow, the time, I think it's 3 to 4 o'clock. I forgot which track it is. So go look out there if you would like to see more information. Okay, so next I'm going to talk you through some of the security enhancement. The first one I like to talk about is CICS support for JSON Web Token. So this is a JSON format security token, and it can be generated for web browser to for client to sign in and to carry on the conversation with the server. So CICS enhanced this verify token command, which you can use it to generate and also verify the JWT tokens, and which, so for example, we enhanced the verify token with the JWT option as well as a basic auth option. So really the basic auth option is for you to for the client to provide user ID and the password. Then for the RACF to generate the JWT token as an out token to the client. Then when next time the client with another request, it supplies that token and tell CICS that it is a JWT token. So this is as a packaged support for JWT. And also we made a lot of enhancement around the security in CICS. So we provided a new domain statistics for security domain. So security domain handles all the authentication requests for all kinds of tokens, for example, password, passphrase, MFA multi or authentication tokens and passkey Kerberos, etc. So it with those statistics, you can see how many authentication requests and gone through CICS for the security domain to look after, and you can also find out how many JWT token being created, and how many authorizations on the CICS resource, on CICS command, and any surrogate authorization request also gone through the system. Also, for example, what's the number of ACEs with and without ICRX, and what's the waiting and the in-flying request to the enterprise, those managements of security, for example, the RECAF. And also we enhanced the user domain statistics, including new fields on how many user instances being deleted, either because the user have signed off or because CICS received ENF notification to tell us the user instance is has been deleted. And also can tell you how many user instance in directory in timeout. So if they're still in directory, you will be able to reuse those user instance without re-authenticate them. So and also we provide 4 monitoring fields, which can monitor the elapsed time a user task spent on verifying the authentication credentials, which showing up on the upper part of the page. So, for example, how many times this task has spent on verifying a JWT token, a Kerberos token, etc. So those hopefully will help you to enable more security. You'll be more confident with security support to your application. So next one is around the CONFDATA. CONFDATA is a SIT parameter. We have provided this CONFDATA as a SIT parameter for enable to redact some confidential data, for example, password from trace, which include internal trace in dumps. However, with this option, we do not redact any storage in the dumps. So in version CICS 5.5 and earlier, the CONFDATA has option of show or hide TC, which is for terminal control only. So the default is to show, which means CICS will not redact the confidential data from the trace. In 5.6, we changed the default value to hide and leave the show as another option. And we use the hide option to replace hide TC because we have increased the trace points which CICS will redact the confidential data. So not only terminal control, but also web and web service trace points and container contents, etc. If you wanted to temporarily change the setting, and for example, you want to gather some trace data, and you do want to see those password confidential data in the trace, you can use the CSFE transaction as using the debug CONFDATA to change it temporarily, and you can change it for all transactions or only for certain transactions. So in the screen, in the bottom of the screen, you can see I'm showing you a trace which has this redacted credential there. So when you see a trace which has suppressed by CONFDATA equals to hide, which means CICS redacted this part of data because you've got the CONFDATA specified as hide. So next around the security is called SNI extension. So SNI is a server name indication. So why what's the relation of security with SNI? Because CICS can act as a HTTP client. It can use a TLS connection to a virtual host. Then CICS may send a request on behalf of one virtual host, say host A, but is sent to a server. That server may support multiple virtual hosts. So say that server support A and B and C, etc., but using a single IP address. Without the SNI extension support, that is an extension to TLS, then the client will not be able to tell which virtual host it represents to. So CICS now added the support. You will be able to request to a server under the TLS, and it can differentiate which virtual host this request come from. So we can see in this diagram to show you two client systems. One is called eSupermarket, another is called eClothes Shop. And these two virtual hosts, they're hosted on the same server called eCorporation, that big server. So with the TLS SNI extension, then the request from the client will be able to send the virtual host name, and the server system will be able to then pick the certificate which is applicable to the appropriate virtual host for that client to go back to the client, then for the authentication. There are a couple of other security enhancements. So for example, so one here is there are category 3 transactions, which including CESM for sign on and CSF for sign off, etc. They do not need a command authority. So in 5.6, we have removed that requirement. Then when as a default user ID, then you do not need command authority for those, for any of the CICS transactions. So same way you're managing the command authority setting for the default user ID. Okay, so next part is going to go through the resilience. So how CICS enhance its the functionality itself to help you to protect against any large request. For example, anything which can cause a storage short of storage example. For example, you may aware CICS is good at monitoring the dynamic storage area. So when CICS start up with a region limit size, it will go and grab this whole lot of storage. Then it will, CICS itself will manage the called the dynamic storage area in this yellow part, and it can tell you which DSA, whether it's 24-bit or 31-bit or 64-bit, whether it's go beyond any limit, there is any SOS sort of storage conditions. However, CICS doesn't manage the bit above that, which is we call it ZOS storage, or in another term called MVS storage. So when those storage would be used, it's been this part of storage is used, for example, when a CICS task requires a new OpenTCP. There is no existing OpenTCP available to run this CICS task. Then CICS will require to start a new TCP. So at that time, it will start will use the storage in this ZOS storage area. So that's one way of using that ZOS storage. But also there is some ZOS get main commands with unconditional get main commands, which can also make use of that ZOS storage area. So we've introduced a monitoring over this ZOS storage, and the monitoring will monitor through tiers. So as the storage usage getting closer to the top of the usage of this part, we will emit messages. So for example, you will see new message will be issued as CICS initialization time, and there is system task will check periodically of the storage. So there are two, here shows you two messages. One is for 24-bit, one is for 31-bit. It will show you startup time, what's the unallocated storage, what's the largest contiguous area is for these two different areas. If that part is getting to the SOS, it will also emit message for 24-bit and 31-bit with different message number, one as you can see here. In the Java session where my colleague Phil Wakeling, he will talk about more around this MVS storage monitoring, because JVM is also a big use on that area. So I'll save some for that. So we also enhanced the statistics to report on the MVS storage usage for the user region and the extended user region, which is 24-bit and 31-bit. It can show you what's when that monitoring sample was taken and what's the state, whether it's SOS or it's not, or it's normal, and what's the low watermark, what's the current unallocated, and what's the last time the SOS happened for that particular MVS storage, and is any task waiting for it, and what's the peak time of task waiting for it. So task, if it requires a new OpenTCP, for example, when that SOS is happening, then that task will put to wait until the SOS is relieved. So those statistics will show you how the region performs regarding this when the SOS happens. So the next one is about non-RLS and RLS. If you access a file control through file control request through to vSAM file, you may end up in a deadlock situation, which causing AFCG event. In a non-RLS access mode, there is a SIT parameter called CI-lock equals to no, which can prevent that happen. So for example, in the same unit of work, the transaction may issue a delete, then read update, or and a delete, so that there's a conflicting request during that URW. So with this CI-lock no, that can making the delete not to lock the CI, so which will not causing the AFCG event. Then if you're looking to move into RLS access mode, you can also having the same effect for the non-RLS that SIT parameter is. You can use the feature toggle called com.ibm.kics.rs.delete RIDFLD equals to true. So which will achieve the same effect as this CI-lock to no for the non-RLS. Okay, so the next part is about stored tasks in the system. You may not look at the CICS trace very much. However, if there is a task stored in the system and you do want getting some trace for problem diagnosis, you may find the internal trace table doesn't contain that task anymore, because the internal trace table may have wrapped. So the entry for that task is gone because it has been suspended for a long time. So it's not possible to see what happened to that task for that part. So for in 5.4, we introduced a stored task trace function. So we now can preserve some trace data for each task in the system. Then we would keep the data for most recent of 20 trace entries. Those trace entries, they are not overwritten if the task suspend for a long time. Then the system dump formatter will be able to format out those new trace data. So the next slide, you can see you'll be able to use this TR equals to 2 and the TRS equals to KE_NUM, which is kernel number. 6E is a hex representation of the task number. So here it shows a formatted out trace entry for that particular task. It's 00128. Here it tells you for the most recent 20 trace entries, what time it did, what's the address at that time, which TCP address is, and what CPU it ran on for when that trace was taken, and what's the function code, the response code, and the reason code. So that would be very useful when, for example, service organization come to diagnose what happened to a task which has been in the system for a long time but suspended. Okay, so the last two parts I'm going through is around the CPSM enhancements that are all around the data space. First one is around the CPSM. You can get a very large API request. So for example, you can get a large request coming from copy, create, expand, etc. Then those requests, it come to a CMAS. It can use all the CMAS data space storage. For 5.5 and earlier, the CMAS can terminate if exceeding the available data space storage. Then you will get this two message, EYUXC0023S and 24S, to tell you that the data cache limit has been reached. Then CMAS is terminating. So for the 5.6 version, if an API command do come with a large API request, which can cause that which the CMAS cannot provide enough that storage, that API request will fail with a condition called environment error. So error with a reason, SOC resource for those kind of large requests. So those applies to the CPSM API request, which is showing on this line. And also you'll be able to see the data space utilization warnings when the data space usage exceeding the tiers, which predefine the tiers, which 70, 80, 90%, and 95%. So with that, you will be able to get this warning and be able to act on before it get to storage used up condition. The CPSM BAS, we also enhanced it. It can now use all the available data space storage. Then if you have a very large CICS environment, it can deploy with a large resource. You can deploy it, spread multiple data spaces instead of constrained into a single data space. So for this one, we've enabled it through a feature toggle by default, but you can disable it through a feature toggle called ComIBM CICS CPSM BAS large CICS equals to false to disable it. So also this feature is available in 5.4 and 5.5 through APA 196.761, but it's disabled by default, so you need to enable it. So, okay, so we have went through all the CICS version 5.6 foundation enhancement, which is a subset of all the CICS portfolio enhancement during the 5.6 timeframe. Those enhancements will, it delivers the core capabilities through those themes around application development management, security, and resilience. So I'm hoping you got a good hands on the 5.6. And also, if you want to know about more information about those enhancements, you can visit the Knowledge Center of the CICS TS version 5.6. Thank you for listening. If you have any feedback, please do so for the session 2AE.
Thank you so much, Jenny.
Thank you.
Good session on compliments from Steve in the chat. Well done. We don't have any burning questions as far as I can see. So just a short reminder for me again, if you can do your feedback, it will be greatly received. Tomorrow we have two CICS sessions, room 3 session 4, 1:30 till 2:30 p.m, which is Ezrael Gross. Some of you may know Ezrael. He's doing a session on CICS Performance Analyzer and its latest updates, including getting all that important performance data into Splunk nowadays, which is a flavour of the month. So that could be a good session. And then, as Jenny has already mentioned, we've got Phil Wakelin tomorrow, room 1 session 5. He's got the Java update for CICS 5.6. And at the end of that, you've got me with a very brief overview of a Java POC deployment of a Spring Boot application that we've done recently during lockdown, and some success there. If you're expecting an in-depth technical analysis of it, you might be disappointed, but I'll certainly try and say what we did have to do to get it working, which wasn't much really, and that was on a 5.4 system. But there'll be a short update on that tomorrow. So thank you again for your time, everyone, and we'll see you soon. Cheers.
Thank you.
Thank you.